Okay, we're going to start looking at exact values for 45 degrees. Our starting point is that we need to have the right triangle. So the triangle that we start with in this case is the right-angled isosceles triangle, giving us 45 degrees here and here. The side lengths that we use are 1 and here it's also 1. That's our starting point, having the correct triangle. The next thing we need to do is to find the value of this missing side. We do that using Pythagoras. So what we're looking at here with the hypotenuse is that that side, square of that side, is equal to the sum of the square of the other two sides. So in this case we find out that x squared is 2 and therefore x is root 2. This means that we now have our triangle with all three sides clearly labelled. Our final step is then to think about the trigonometrical ratios. So if we take this 45-degree angle here as the angle that we're working with, we can label the sides accordingly. This would be the hypotenuse, this would be the adjacent, and this would be the opposite. We can now use what we know about sine, cosine and tangent to find these trig ratios in their exact form. So if we're looking at the 45-degree angle there, then we know that sine 45 is going to be equal to opposite over hypotenuse, and therefore here we find out that sine 45 is the opposite, that's 1 over the hypotenuse, which is root 2. For cosine, we know that cosine of that angle is equal to adjacent over hypotenuse, and in this case that means that cosine 45 is equal to adjacent 1 over hypotenuse root 2. Finally, for the exact value of tan 45, we know that tan 45 is equal to opposite over adjacent, and this means that tan 45 is equal to 1 over 1, which is therefore equal to 1. We now have our exact values. We have sine 45 is 1 over root 2, cos 45 is 1 over root 2, and tan 45 is equal to 1.